everyone. My name is Danny Southerly. I am the Regional Account Manager for Verisurf Software Solutions. I'm located out of Dallas, Texas. I cover 8 states, so the entire South Central United States is my territory. And I'm happy to be here, and thank you for your time today and joining us. And hopefully you'll get some information that'll pique your interest, and you'll want to explore the power of Verisurf a little bit more. So I'll do a small little PowerPoint presentation, then we'll get into touch toe probing with the portable CMM arm reverse engineering. A little bit backstory on Verisurf and where we came from to where we are today. Verisurf is headquartered out of Anaheim, California. Started back in 1989, mainly trying to meet needs through the aerospace industry. And you can see over the years the milestones. The first release in 1996, they incorporated in 99. Auto inspection was added in 2003. And then the demand by Boeing 787 program requirement for model-based definition to eliminate blueprints. So now we're handling intelligent CAD with MBD and GD&T tolerances embedded. As we move along to 2008, we released Verisurf X. 2013, we developed a university for training. And this is really cool and unique. You can log online and get all kinds of training through different modules and software platforms tailored for your whatever your application is. In 2014, we released an Automate module for programming and automating CMM and machine tools. 2018, Universal CMM was released with all I++ standards based. And 2021 and moving forward, we're always leading by continuous improvement and innovation. We're always developing and working close to stay ahead of the game and meet the demands and requirements by specifications. And if a customer has issues or they're trying to achieve something, we're very flexible in trying to work those types of tool packages and enhancements into the development of the future releases. Industry served. As you can see, we're across the spectrum. We've got tons of customers, and I'm sure some of you are familiar with, probably work with or know of across all industries. We are an open measurement platform, meaning laser trackers, optical trackers, scan arms, probe arms, structured light, handheld scanners, CMMs. We interface with hundreds of instruments. We're the software package that you're capturing the data in, doing your analysis, doing your modeling, and interfacing. We work very close with the OEMs and integration with new product lines that are being released as well. Some of the type of file formats that we're able to utilize, something that a lot of people don't realize with Verisurf is we're built on top of Mastercam. So that makes the power of us working with Mastercam customers a happy marriage, so to speak. The design side of Mastercam, I mean, not the tooling and toolpath side. So the design side of Mastercam is our CAD side. That's our CAD platform. We're the only company that provides measurement data, accepting measurement data that's built solely on top of a CAD platform. That sets us apart from all of our competitors. And as you can see, we handle numerous types of file formats from all the natives, optionals, and the standard industry. We can export and import, or we can import these types of file formats. And as I said, the Mastercam Partnership makes a common platform for closed loop design through the manufacturing process. So you can kind of see we're entwined, and it kind of streamlines and optimizes the manufacturing process utilizing Mastercam along with Verisurf. When it comes down to metrology applications and complexity, people have a lot of questions. You know, how difficult is it? How much training is involved? You know, how much is this going to cost me? So we kind of put this little chart together to kind of give you a better understanding of what you can expect out of system cost and knowledge and experience levels. Today, we're going to be falling in the lower end of the spectrum down here. So we're going to be using just a portable CMM arm, a Master3DGage with probing, and we're going to be touch probe data to reverse engineer. So you can kind of see we're going to be in the mid-range using CMM arms and reverse engineering. Once you get up into CMM inspection and laser trackers, you're on the higher end of the market and a little bit more complex when it comes to training and learning. Still easy and simplified through the optimization workflow that we provide in the training, but you kind of get an idea of where you're at and where you can end up as you gain knowledge and experience and you continue to grow. Verisurf application suites. We offer several application suites, or you can get an all-in-one, which we call our enterprise bundle. So this is going to encompass anything and everything that Verisurf offers when it comes to CAD measure, model, automation, CMM, programming. It's the whole gambit, so to speak. If you don't need certain types of capabilities, we have them built into different packages, so we consider ourselves modular based, which then reduces the cost of the platform. We have 3D scanning and inspection, CMM programming and inspection, tool building and inspection, 3D scanning and reverse engineering, guided assembly inspection, and just good old inspection, CAD and measure. Verisurf is very, very proud to show the ease of use and workflow. It really simplifies utilizing the software. There's so many softwares you can get wrapped around the wheelhouse trying to figure things out, so many icons and buttons to click. Verisurf makes it very, very simple through, simple, easy, concise practices and workflow. And in the inspection side, you're always going to align, measure, and report. You're importing a CAD model, you align to it, you inspect the features, and then you report it. And out the door it goes. In 3D scanning and reverse engineering, you're going to see some of that today. We're going to measure some part features. We're going to model the solid. And then we're going to inspect the surface inspection to ensure that the model was done correctly, that the data was good, and you have a good model. What sets Verisurf apart from others? We are a fully Windows compliant experience. As we already talked about, Mastercam design foundation. We have photorealistic rendering. We provide solid modeling and surface modeling all inside our software. You don't have to export and go to CATIA or some other modeling software. You do it all inside of Verisurf. Even drafting, editing of imported models, CAD validation. If you get a model from one of your customers, you can bring that model in and validate it, that all the translations are correct. Model-based platform, all the MBD, ease of use, minimal training, and substantial resources. Our customer support, we pride ourselves on this. We're small enough to listen, we're large enough to take action. We have multiple channels for support. Contacting us at any of these web addresses, or contacting your account managers, your salesmen, you're talking to the people who are helping you. You're not going into some call center and being passed around. Like I said, we're small enough to listen and large enough to act, and you get a very close rapport and relationship working with us. You get to know the people who are helping you and coming to your job site and working with you and making you successful. So here we are, and we're here to support. Like I said, we take pride in our customer relationships. We're a team. Your success is ours. And we support when others won't. Our teams are on the hook all the time. You can call us and somebody's going to be answering, even late hours. Just last night, we worked until about 11 o'clock at night here with the customer. Didn't even blink an eye. So our support is par none. Okay, so we'll get into some fun stuff now. Master3DGage reverse demo. As you can see on the left-hand side here, because you won't be able to see the instrument while I'm doing the demonstration, we'll be using a Master3DGage portable CMM arm with the touch probe. And this Master3DGage block, a real simple part, that's what we're going to be building. We're going to reverse engineer this part. So here we are, Verisurf. So as you can see up here on the right-hand side, it's going to be my device manager. It's a Master3DGage arm. And I'm not going to get into all the details and muddy the water right out the gate. I'm going to go through the workflow and start showing how we're going to measure and build this part. First thing first is I'm going to want to measure a base plane. So I've got this aluminum Mastergage 3D part. It's about 4 inches by 7 inches and 1 inch thick. I'm going to measure a base plane. So I simply hit the plane over here on the side. It's named base. 4 points using least squares fit, comping down from the probe using single point measurement mode. So you see the fit of flatness is 5 thou, and that's because I'm in a hotel room sitting on a desk table here doing this demonstration. I'm not on granite or solid. You'll get better results when you're in an environment that you'll be truly reverse engineering. So fit that to screen, you see I got a base plane here. Next thing I need to do is I need to measure some features so I can create an alignment. So I'm going to measure a line along the front face of the part and then another line on the left-hand side of the part. So I select line over here, line, 2 points, and I'm going to project this line to the base using single point. You can see my probe now. I'll measure a line across the front. And a line across the side. And done. Now you see those lines and planes are on the same plane. It's projected down to it. Now with those features measured, I need to build a working coordinate system on the part that will be relative to the part so we can model it. So I'll select the base, the line, and the line. They're highlighted. And I create what's called a feature alignment. The feature alignment, you can see we have a coordinate system now. The primary plane being base 1, the line axis being line 1, locking the Y direction, being X positive run, and then the origin, the intersection of line 2, line 1, and base 1. So now it's locked right on the corner of the part. Moving right along, we now need to measure the right-hand side and the back side of the block. So we need 2 more lines. Again, project the base, single point. And done. Now we got 4 lines in our base plane, all on the same plane. Now we need to connect the perimeter of this part. So we can do that simply by highlighting our lines and using a function we call trim lines. This will extend at the intersection and trim off the edges. And there you go. Now we need to take these lines and export them to CAD. Now we have CAD entities, and we can turn our features off, and there is the perimeter of the block in CAD, 2D, right there. For time purposes, I'm not going to measure the radiuses of these corners. I already know what they are, so I'm going to do a little bit of fillets. So a fillet's going to add the curvature to the part on these corners with the radius of 250 thousandths. So I select the wire chains and it curves the part out. So now we got some curved edges there with the radius on it. And if you remembered in the picture, we had an S curve, top down view here, of contour on the front of the part. So that's going to be a spline. So next we need to measure a spline there. So we just hit our spline measurement, project the base, and this time we're going to use continuous mode because we're going to scan data points. We're going to set a filter of spacing of every 100 thou, Turn off post-processing. And now we're going to scan points across the front face here and get the spline. And done. So now that we have the measured spline, you can see the offset of the points there. Now that offset is because we have a probe radius right here. The software automatically knows that you're utilizing this probe radius, so when you create the geometry, it offsets it. Now we need to export this to CAD. Now we have a CAD spline. You notice we got some gaps here, so we don't have a complete part. We need to modify the length ends of this spline to intersect. We have a tool called Modify Length. We're going to modify it. Let's go 1/2 inch to make sure we got a good intersection. We select the end of the line and the end of the line. As you can see, it now intersects. Now we need to cut those little tails off and cut off this chain link here in the middle. We're going to do what's called divide. We highlight the chain, it's gone. Come to the corner, gone. In this corner, gone. Type trim. Now it's starting to look like that part. Now this is all 2D wire on top-down view. We've got something called levels over here. So our first level that's visible, we're going to call that wire. We're going to make a new level. We're going to call it level 5, and we're going to call it solid. Now that we have our 2D wireframe, we want to extrude this and make it 3-dimensional. So I'll highlight this, extrude, select my chain, cube mode 3D, wire chain, hit OK. Now I know my part, because I took the steel rule, is roughly just shy of 1 inch thick. So my distance to extrude, I'm going to set it at 1 inch. Create body extrude, hit OK. Starting to look like the demo block a little bit more now. Next thing we need to do is, we know that there's a contour surface here. Okay, so we're going to make a new level, call it level 10, and we'll call it surface. Come back to measure, and we're going to scan a bunch of points across that contour surface so we can build a surface patch and cut that part of the body off. So I'll come to my points. Cloud name is going to be contour. We're going to go continuous mode. I'm going to set a filter. Every 200 thousandths, we'll take a point, and then I'll do an active filter the same, meaning it won't allow 2 points to sit on top of each other. It's going to make sure that if they're close, they're going to be within the 200 thousandths and be spaced out. So now I'm going to scan the part. I'll put this into wireframe mode here, so I think you guys will be able to see it better. So we got a wireframe there. I'm simply holding down the trigger button with the 6 millimeter ruby ball, and I'm going to scan points on the top surface of this part. So right now I'm outlining the perimeter. Now I hit the internal body. Just trying to get good coverage so I make a good surface patch. All right. So now you can see we got data on the inside here. So with that data, we need to come to our point clouds and fit a surface patch through them. Max deviation 10 thou. My UV control is going to be like my X and Y plane grid of 22 and 22. And we're going to extend the difference beyond the surface so we can cut it off at 0.375 using probe offset from the arm. You know what that the software knows what that is defined. It's over here on the right hand side. And we're going to create surface. So now we have a surface patch through the part. So when I put this back to solid, there it is. Now we need to get rid of this upper piece here. So we're going to trim by plane. Surface sheet. Select the body. Select the trim. Trimmed it out. Okay. Come to our levels. Turn our solid on. Surface off. Wire off. Turn our point clouds off. There you go. So real quick and easily, we're able to measure the perimeter, measure some features, and pick up everything that we need to do to reverse engineer this block. Now that we have this block shape and form in a solid CAD model, we can go into inspection mode and we can verify that we modeled it well. Let's go solid. As you can see, the green means go. We got good surface here based off the surface patch. We come to the front, it knows where it's at. The sides, everything's looking good. Looks like we got a model that was built to the exact dimensions of the part. Yeah, we picked up a bunch of point cloud points earlier. You can also come into analysis and you can select your point clouds and we can look at the deviation status of all those point clouds relative back to the top surface also. And that's about it. That's how fast and easy you can get into a part and measure a part using some simple geometry features and modeling. Does anybody have any questions?